All right, ladies and gentlemen, we're looking at applying properties of chords in a plane and angles whose vertex is the center of a circle is called the central angle. We talked about that today in our warm-up. So we've got a circle. The central angle goes through the center of the circle, okay? Gives you a central angle. If the measure of a central angle is less than 180, it's a minor arc, greater is a major arc, and then we got a semicircle. We've talked about all these things before. We're going to skip down to theorem 10.3. In the same circle or congruent circle, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay. And a diameter of a circle is perpendicular to a chord, and the diameter bisects the chord in its arc. Let's make some pictures for these. Okay, we're looking at 10.3. We've got in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if these two chords are congruent, these two arcs are congruent. Okay. If a diameter of a circle, here's the diameter because that's the center, of a circle is perpendicular to a chord, so here's a chord, then the diameter bisects the chord and bisects its arc. Okay. If one chord is a perpendicular bisector of another chord, then the first chord has to be a diameter. In the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So if we want to say these two chords are congruent, the distance from them to the center has to be congruent. Okay? All right, let's go through and find the measures of these. All right, we've done some arc work before, but we're going to do some arc work not just from central angles, but from chords. We want to find the measure of M to N. Well, if I know this is 175 and I've got these little lines here, that means, oh, sorry, 135. If I know this is 135, what's this one? 135. And so how would I find out what this? Okay, so let's do that. So 360 minus 135 minus 135. Yes. 135. They're equal to each other. So the measure of MN would be what? 90. 135 minus 135. Yep. Did I lose people? Okay.
So you add 135 and 135.
Let's go over this again. Let's back up. Shh, I need your full attention. Do we see that these two arcs are congruent?
Yes.
So if this is 135, this is also 135. Ugh, I hate it when it does that. Okay, the interior angles of a circle add up to?
360.
So I'm minus 135 minus 135. I'm left with 90. Good? Okay. If this arc is 85 degrees and this arc is 65 degrees, what is arc MN? How am I going to find that out?
You're going to subtract sum of 85 and 65.
So I'm going to, from 360, I'm going to subtract 65 and minus 85. And I'm left with 210. And then I'm going to take 210 and do what to it? Divide it by 2, so I get 105.
Why do you divide it by 2?
Because both of those have to be equal to each other. Because we only took away, we've got 4 angles, right? We've got arc 65, arc 85, arc 105, arc 105, okay? So if I took away those two, I know I've got 2 arcs left that are equal to each other, so I divide it by 2. And I get that the measure of arc MN is 105, and I know that that is congruent to arc QP. Okay, what about here? I know this is 130. And what do I know happens?
It's bisected, so.
It bisected, so those two lengths are congruent, so the two what are congruent? These two arcs are also congruent. Okay? This arc has to be congruent to this arc, so they both have to be 130. So again, I'm going to do this in threes. 360 minus 130 minus 130. And I get 100, but is 100 what each of these arcs are? No, what are each of those arcs?
50.
50. This is 50. This is 50, but it actually asks us for M to N. So what is the measure from M to N?
100.
100. Okay. Let's turn it over and look at the back. Because it says from M to N. See where M is? See where N is? Yep. All right. I'm going to use properties of arcs and chords to solve all of these problems. Okay. So I've got that QV is 2. So I'm just going to draw it in so I remember. I know that Q to U is also 2. I know that SU is 3. And I want to find out what B to R is. This right here, that's what I'm trying to find. Okay, so let's think about what we know about properties of chords. So, which theorem would I use from the front for these properties of chords? So my picture, these are both 2, and this right here is the center. 10.6, they're equidistant from the center. So in the same circle or congruent circles, 2 chords are congruent if and only if they're equidistant from the center. Okay, so I know this whole thing has to equal this whole thing. Okay, I'm going to have to use another property. If a chord is perpendicular to the other chord, the first chord is the diameter. If a diameter of a circle is perpendicular to the chord, the diameter bisects the chord. So that means both of these sides are 3, right? So that means
That's not.
the whole thing has to be what? 6? Okay. Because we're adding, not multiplying, right, DeAndre? Okay, so V to R would have to be V to R. 3.
Oh my gosh.
Okay. He knows the right answer. He's just answering the wrong question. All right. P to S, so this whole thing is 12. T to V, this whole thing is 12. We know Q, S to Q is 7. And we want to find Q to U. Right there. My chords are congruent, which means what else has to be congruent? If 2 chords are congruent, they have to be what from the center? Equidistant means the same, right? So QU and RQ have to be the same length. We're okay there so far, right?
Yeah.
All right. We also know if it's perpendicular, it's dividing this in half. So I know both of these halves are 6, correct? Do we see that we have a right triangle? How would we figure out what x is? Pythagorean theorem. 6 squared plus x squared equals 7 squared. So 36 plus x squared equals 49. So 49 minus 36 is 13. And the square root of 13 is 3.6. It's approximately 3.6. And we know it's the positive version, not the negative version, right? Because we're talking about lengths, because we don't usually have a negative length. Okay, so we found R to Q, but we also know that's the same as Q to U. Okay. All right, do you see how you're going to have all of these theorems in front of you and be like, oh, this is a chord. I'm going to get my theorems that talk about chords. So maybe when you write these down, you should put at the top of like that section of your vocab that these are chords, chord properties. So when you get to a chord, you know which properties to look up in order to solve. Does that make sense? Okay, let's do another one. All right. We know that D to C is 8. We know this whole thing is 8. We know P to Q is 3. And we want to find A to P. A to P is a what? It is a radius. Let me ask you this question. Is this also a radius? P to D. Do we know if this whole thing is 8 and these two lines say that they're the same, then those two lines are both 4. So do we see that we have another? We know P to Q is 3, and we're trying to find this. 3 doesn't go here, it goes here. If that helps.
All right.
Okay. So we've got to find the radius. What would the radius be? A to P, or any radius, would equal 5, because it's a 3, 4, 5 triangle. 3 squared plus 4 squared equals x squared. Solve and you get x equals 5. Okay. What do you think, guys? One more?
F.
You had F? Sure. This length is 3. This length is 8, so I know each half is 4. The radius from here to here are both the same. So then I have a right triangle. 3 squared plus 4 squared equals x squared equals 5. I know it's a 3, 4, 5 triangle, so I just skipped the Pythagorean theorem. Okay. Yes.
Hold on. Go back to C4. Hold on. All right. So I was thinking that X was where you found D to P, right?
Okay. Yes. X is D to P. But D to P and A to P are equal because they're both radiuses. And the radius of a circle is always the same. Does that make sense?
Yeah.
Okay. All right, let's go to F. All right. C to A is 3. And I want to find X to Y. Okay, if this is 3, this side is also. So X to Y has to be the same because they're equidistant, so that's
6. Wow.
This is 3, so this is 3. They're equidistant from P, so the chords have to be the same, so it's 6. Okay, let's get out your handy-dandy notebooks so I can read to you.